and welcome to another edition of Math is Still Math. Today we're going to be doing some 8th grade geometry. We're going to be finding the volume of 3D shapes, most notably the cone, the cylinder, and the sphere. So we're going to get right into some practice problems. I hope you follow along on your own paper. I've got the formulas here. The volume of a cone is 1/3 pi r squared times the height. The volume of a cylinder is pi r squared times the height. And the volume of a sphere is 4/3 pi r to the third power. Now we're going to get using them here on my paper. Follow along. Pause the video at any time to try and work the problem ahead of me and then see if you get it right. Let's get into it. So here we have a picture of a cone, and the first thing I'm going to do is write down whatever information the picture gives me. So this says that the diameter of the cone is 16 meters because that line goes all the way across the base, and it says that the height is also 16 meters. So that's the first thing I do is I write down the stuff that I know based on the information that is given. Well, the formula for a cone is 1/3 pi r squared times the height. Thing is, they didn't tell me what the radius is, but I can figure out what the radius is if I divide the diameter in half. So from here to here is the radius. Half of 16 would be 8. So that means the radius is 8 meters. And that's something I had to think of on my own. The problem is not going to tell me to do that. But once I know the radius, I just get to plug it in and do the calculation. So this translates to 1 divided by 3 times pi. The value for pi that I'm going to use today is 3.14 times the radius squared. That means I need to multiply times the radius twice. It would be times 8 times 8 times the height, which is what they gave us, which is 16. So I'm going to pull up my calculator. And let's see what that comes out to be. So 1 divided by 3 times 3.14 times 8 times 8 times 16. Okay. So that would be 1,071. I'm going to round it to the tenth place here, 0.8 meters to the third power. There's your volume. So that's how we get the volume of a cone when they give us the diameter of the cone and the height. Let's do another one. So this cone's a little different. The position is sideways, sort of, but we still have some information here to gather. Just based on what I'm seeing, I can tell that the height of this cone is 18 kilometers. Wow, that's a big cone. And the radius is 9 kilometers. Okay. So if we want the volume, we need to write down the formula, which is 1/3 pi r squared times the height. And now we'll just replace the variables with the numbers we know exist. So that would be 1 divided by 3 times pi, which is the value I'm going to use is 3.14. Times the radius squared. The radius is 9 kilometers, so that's 2 9s. Times the height, which we see is 18. Yeah, there's really no mystery to this one, so I'm just going to pull up my calculator. do 1 divided by 3 times 3.14 times 9 times 9 times 18. So the volume of this cone is 1,526. I'm going to just leave it rounded to the whole number here. So it's about 1,526 kilometers to the third power. Finding the volume of cones. Pretty simple. If they give you the radius and the height, it's generally a very simple process. Just use the formula as a machine, pump out an answer. Let's move on to another problem. Okay, this one is not a cone. This one is a cylinder. So we're going to be using a different formula to find the volume of this shape. Let's write down what we know. Based on this picture, it looks like they've given us a diameter of 6 yards, and they've given us a height of 5 yards. Okay, fair enough. Well, the formula for the volume of a cylinder is pi r squared times the height. So we write that down. Pi r squared times the height. Bummer. We'd be able to find this really easily if we only knew what the radius was. Fortunately, I know circles. This diameter, well, half of it is a radius and half of 6 is 3 yards. So that means, stop moving my paper, the radius is 3 yards. So now we can just replace what we know. So we need 3.14 times the radius squared, so that'd be times 3 times 3 times the height, which they gave us, which is 5. So let's get out a calculator. So 3.14, which is pi, times 3 times 3 times the height, which is 5. So our volume would be 141 and 3/10 yards to the third power. Let's do another one. So here's another cylinder, and it's kind of slanty ways, but still not that bad. Let's write down the information that we can learn from the picture. So it looks like we've got a radius of 7 feet, and we have a height of 15 feet. Okay, well, now that I've written down the information I can learn from the picture, let me go ahead and write down the formula for the volume of a cylinder. The volume of a cylinder is pi r squared, that's the base, times the height. Let's go ahead and fill in what we know. So that would mean 3.14 times the radius squared, two of those, that'd be 2 sevens, times 7 times 7, times the height, which is 15. Well, it looks like we already knew everything we needed. So let's just see what it calculates to. So what is 3.14 times 7 times 7 times 15? So apparently, our volume is 2,307.9. That'd be feet to the third power. And that's how you find the volume of a cylinder when they give you the height and the radius. Let's move on to a different problem. So we have landed at spheres. Okay, so this is different from the others. We're not going to have a height. We just have a radius to find. And lo and behold, they have given it to us in this picture. Just by looking at the picture, I can see that the radius is 3 feet. So let's write down the formula for the volume of a sphere. 4/3 pi r to the third power. So, because we already know the radius, we can go ahead and start replacing with information like so. So we're going to do 4 divided by 3 times pi, which I'm going to use 3.14, times the radius 3 times, and I need 3 of these. That'd be 3 times 3 times 3. So let's see, what's 4 divided by 3 times 3.14 times 3 times 3 times 3. So apparently the volume of our sphere is 113 and 400ths feet to the third power. And that's how you find the volume of a sphere when they give you the radius. Let's try another one. Okay, this sphere is very similar and yet slightly different. You see, they did not give us the radius. In this one, the given information in this picture, they tell us that the diameter is 12 centimeters. So when I write down the formula, 4/3 pi r to the third power, and I say to myself, well, goodness, this would be easy if only they told me what the radius was. But I'm good at circles, and I understand that halfway across the circle is the radius. So if the whole way across is 12 centimeters, then halfway across would just be 6 centimeters. Make sense? Okay, well now we can go ahead and replace letters in our formula. So that'd be 4 divided by 3 times pi, which is 3.14, times the radius 3 times, so that'd be times, we just figured out the radius is 6, that'd be times 6, times 6, times 6. And that would be the volume of the sphere. So let's see what that is. What is 4 divided by 3 times 3.14 times 6 times 6 times 6. So the volume of this guy would be 904 and 3200ths centimeters cubed. And that's how you solve the volume of a sphere when they give you a diameter. So the last thing I want to talk about today is how to move backwards for a formula and undo steps in case you don't start with a radius or a diameter of any kind. You might need to find those things once they've given you some information. So I'm just going to go ahead and make up a problem here. Let's say that you were given a cylinder okay, and they go ahead and tell you a couple things. Like, let's say they give you the height is 10 feet. And they tell you that the volume is 325 feet to the third power. But they don't tell you what the radius is. And they actually want you to find the radius. Now, this is where you're going to have to do some undo math. So you will still start with the formula for a cylinder, which is pi r squared times the height. That's the volume. So now we're going to replace things that we know. For instance, we know that the volume is 325. We know the height is 10. We don't know what r squared is. We don't know what the radius is at all, but we do know that pi is 3.14. So we have the pi times the radius squared times the height equals the volume. But we need to figure out what the r squared is. So here's what we're going to do. I'm going to go ahead and multiply. I can rearrange this multiplication. I can say 3.14 times 10 times r squared. That's the commutative property of multiplication. So I can go ahead and do this first. Well, 3 and 1400ths times 10 would be 31.4 times r squared times, equals 325. Now here's the undo step. Right now, r squared is being multiplied by 31 and 4/10. But to undo that, to get rid of it, I'm going to have to divide by 31 and 4/10, like so. Now, the equal sign is a symbol of balance, so whatever I do to one side, I have to go back and do to the other side. Now, as math teachers love to say cancel out at this moment, 31.4 divided by 31.4 is going to be 1. It's like multiplying r squared times 1. So it's almost like we're not doing anything. So r squared is left over, and quick calculation, 325 divided by 31 and 4/10. 10. I'm just going to round this to the hundredths place. 10.35, and it goes on forever. Now, the last undo step to get the radius. We have to find the square root of both sides. Depending on what calculator you have, your button will look different than mine. So I have to switch my calculator into scientific mode. And my square root button is right there. It almost looks like a check mark on mine, but on yours it might look very different. And on your calculator, you might have to hit a second key or a shift key and then strike a button that's below this symbol. It just depends on the make and model of your calculator, of which you should own one. So I'm going to type in 10.35, which is a very good approximation for what I just had, and hit the root button. And the square root of 10 and 35 hundredths is, I'm going to round this again to the hundredths place, so it would be 3.22. So R is about 3 and 22 hundredths. So that's a very good approximation for the radius. And that is how you do undo math when you start with volume. Regardless of which formula, whether it's a cone or a cylinder or a sphere, if you have to start with the volume and work backwards, these are the steps you're going to follow regardless of the shape. You still use the formula. You still plug in the information you don't know, that you know. And then you start doing some division, undo steps, and then a square root, or if you're doing a sphere, a third root at the bottom, to finally figure out what the radius is. And then once you have the radius, you can figure out anything about that shape. I hope it's been an instructional video. Contact me if you need more examples. Leave posts and comments. Please just remember that math is still math.